This session is particularly focused on release engineering for a Polyglot team when you have more languages being used in an organization like Freshwoks. I'll talk about why we should be worried about release engineering, what is important about release engineering. I'll then talk about what are the challenges that we are facing in Freshwoks. I'll expose the complexity that we deal with and how are we solving the release engineering problems during build, test and deploy. I'll even take you through some of the orchestration and observability that we do internally within the organization. A show of hands, how many of you deploy multiple times a day today? How many of your teams? Yeah, I see 2, 3. How many of you at least deploy every week? More hands. I'm not going to ask how many of you deploy every month. That's off stage. I'll come and connect later. But yeah, I think we are pretty much dealing with these DORA metrics. DORA metrics is DevOps, research and assessment. It has these 4 key metrics measured as a proxy for organization performance. When I say organization performance, it is for the speed at which you go to the market and the speed at which you get feedback from customers and the security and compliance related reaction that you do when there is a threat and developer burnout. All 3 are measured under organization performance, and high performing organizations have these measures. There's just 1 day lead time from the commit to production. So when some of your developers are committing or you are committing, it should go to production within 1 day or at least a week to call ourselves a high performing organization. And there should be on-demand releases, which are multiple releases every day, so that the release pipeline is unblocked, and MTTR is mean time to recovery or resolution. It should be less than 1 hour. And when you have multiple deployments, the failure rate should be less than 15% to qualify for this. And is this new to any of you? Just show your hands like this is new. No, right? We have all seen that, and it's there in the magazine given to us today on page number 30. This whole report is there. You should go about it. They have just added reliability as 5th measure. So you can use the Git's magazine for that. So with all this 4, if you see, releases are playing a key role in getting those metrics to a good measure, which is directly related to organization performance. So what are the challenges in achieving that? That's what we are going to talk about. This is a representation of one of our products. It has a monolith at the heart of it, and there are multiple languages being used for different purposes to solve different problems, serving through that monolith as well. And we have this complexity copied across 4 regions for our customers where everybody is reaching out. This is a very basic SaaS model, right? Any software as a solution will have this kind of complexity. And to add to this, if you were in the session this morning, keynote speaker Rajiv mentioned about this complexity in Freshwoks, where we have 1 million requests per minute coming into a single product. I'm not exposing the whole volume. I'm just talking about the sample, which is served by a platform which is for perimeter control and first cut interaction, which comes to the product that we have seen. It has its own complexities, which is again talking to multiple platforms to get things served. So monolith, microservices and platforms all compose together to deliver one single request. That too, it has to be really fast in SaaS world. It cannot be very slow. We have to achieve all this. And when you have thousands of customers, hundreds of features, then it is important that we don't break it. That's where the 15% failure comes in. We cannot afford to have downtimes or breakages in production just because we want to go fast. That's just rash driving, isn't it? So these are all the challenges that we are dealing with, and I will now take you through some of the release engineering solutions. So to start with, we will have a look at the build. So we have multiple services. I just took a sample of Java, Ruby and Node.js. So the way we build these things are different, right? This is compiled and that is interpreted language. It will have a jar file which is immutable to an extent, and Ruby and Node.js is mutable code that is available for people to edit. But what we do is we allow the experts, the developers, to deal with their own ecosystem in their own way. Whatever modern tools that they want to use, it can be used. But when it comes to deploying, there are generic solutions that we deal with. For example, we build the immutable images. We make sure like there is access protection. The files coming from Ruby and Node.js are not editable today in production. Nobody can even install a software like VA editor to even edit it. And there is container protection. These things are abstracted out from the individual teams, and that makes it easy for people to innovate and be very modern while also being very safe in production. That's what happens in build. And how we do this, I'm going to show that in a minute or two. I'll come and connect the dots and look at the test. This is also very specific. Java, Ruby, Node.js, they have their own unit tests and linters like Sonar, Robocops, stuff like that. And we have integration and acceptance tests that are different for each and every language. These are all self-contained units. This can be achieved even within Git as Git actions. It doesn't matter which solution you go for, but these are all contained within the developers. But once that PR, the pull request that goes through review and test process within the developer space, right? There is a stage where it gets into the pre-production kind of stage where it is going to go live next. At that stage, we have generic solutions for our regression and sanity testing because we are a SaaS product for customer and IT employees, right? So it has a lot of features that should be working in even when we deploy. We cannot break anything. That we ensure by looking at the end-to-end tests, which are using a pretty common framework across the company, common language for the end-to-end test, and the teams that are working on can go and support another product if we wanted when there is a business need. This movement is possible because the only thing that is different for any SDETs or key member who's moving around is to look at the product functionality itself, because everything else is common. The language and the framework is known to them. It's easy for them to move around. So by splitting the necessary language specific ones and giving it to the experts and abstracting the rest of it out for a different team, we managed to have this built into the pipeline where it is almost fully automatic, right? So I'll talk about the sanity test, regression test. We have a tool within our organization that tells us for every release, what is the regression result, what's the sanity result in production when it goes live, and we will be able to see this. And the best part of this is actually queryable through API. This tool will tell us if the shipping in India happened properly, is it working fine, before even we think about promoting traffic. We have capabilities to test the traffic only for test accounts and prove that it is still working through sanity and it is 100%, we can take the decision. When you have this kind of queryable model here, it allows you to automate more because you can then plug in another API call and say like, did my sanity complete and is it 100%? Then I can say like move on, switch the next to 10% of the traffic. I'm not talking about the details of release engineering per se, I'm talking about the multiple language problems, but within release engineering you might have rolling rollout, blue-green kind of strategy, you will have canary, and this concept is going to come back again and again where you query the data. I'll show that example as well. We will look at how we are deploying now. This is the interesting stuff. We looked at the build side, we looked at the test side, now we are looking at the final step of pushing into production. There are so many steps, I'm just quoting some of the samples. So if you look at language specific actions, we talked about building assets, packaging into images, storing in different areas. For example, CDN and stuff like that need different storages and unit tests. But when it comes to deployment actions, there are different actions that you take: publishing assets, scaling infrastructure, switching traffic and testing in production, promoting more traffic slowly, getting feedback, and all is deployment actions. But there is a third one. This process automation is also important for a release. When we talk about continuous deployment, the deployment has to trigger from commit, right? That's what we do. Commit will deploy. But when there is increased complexity, when you want to have controlled and predictable deployments, we go for predictable schedules. There are multiple deployments every day that is happening, that is published in a calendar. The calendar is queried by tools, and that will trigger the right deployment in the right space. It's possible to integrate normally any calendar that allows API access and use that as part of your pipeline to trigger releases. We even take release tags in Git during actions that are set up elsewhere. So it's all actions. You can connect that back to what happened in the last session, right? A composable architecture, both in hardware and in software and home furniture. It's the same thing. You can create different actions, keep audit records. We know we have tools that will that will tell us what happened in the release for the last few releases, what happened, which tag went to production. That record keeping is important when there is an outage or a bug to figure out where it went wrong, where it started. So when you have multiple releases going on, you need to have visual representation of which tag is deployed in which region. And that should be also something that we can observe from deployment. When I say observe errors, the previous working build is serving traffic to the customers, right? And the next build that we put in actually is throwing a lot of errors, which is not coming up in the test. The underlying system might show a lot of exceptions. There may be errors which are not detected by test. This is also a part of the deployment pipeline where there should be events that you can say, like the previous build had these many errors in the last 5 minutes, but the new build is showing more or less errors, and then take a decision based on that. That's possible. And if you have to look at that as an automation opportunity, this observing errors has to be instrumented. I'll talk about that as well in the next upcoming slide. We have, I think, half time, 15 more minutes. I'll go for another 10 minutes and reserve last 5 minutes for Q&A, right? And then notifications. Notifications for a different set of people, stakeholders. The developers who are shipping something need to know their code is going live. The QA team who's shipping, they need to be available to test anything that is needed. And the stakeholders, the leadership team should know what features are being shipped when, so that they can communicate with customers. Even marketing team needs to know all that notification. If you try to do that manually, that's not going to work out at all. There should be a space where automatically all these details, both the technical details and product specific business details, are going into notification channels. You can figure out the channels, but the action has to be there. We send it to Slack. We send it in emails. So whoever wants, they can subscribe for the different things. So these are all done through Jenkins, and we have all these actions built predominantly based on Jenkins. Like I said, we also use Git actions. We have other mechanisms. I'll show the in-house tools as well. But Jenkins is the foundation. Jenkins is also a platform within our team. We don't deal with installing Jenkins and having machines maintained, provisioning access. That's all available as a platform for us to use. By doing that, we are now able to focus on building the actions. I keep saying actions. In Jenkins language, it will be jobs. We focus on building jobs. The developers will write what they want. The SRE will write what they want. So it's very kind of decoupled in a way that the focus is about innovation rather than figuring out the maintenance work. Yeah. So Jenkins is supporting both language specific actions, deployment actions, and process automations that we have seen earlier. Okay. Oh, by the way, I didn't mention about the left part. So the Jenkins is not only connected to the orchestration tools. There are crons that can do this, orchestration tools that can use the same Jenkins job, and on demand, people can go and deploy if they want. We are not tied to any tool or the process that we have set up. If that process is breaking down, it's possible for human beings to step in and start the same thing here from Jenkins. So all three are possible. So now if you connect the dots about what all the languages that we have seen, the platforms and microservices and all the actions, this composing deployments through Jenkins or through orchestration tools is able to deploy things to Nginx, S3, CDN. You can do Kubernetes. We are doing Lambda, and we are pushing to app stores for mobile. All that is powered through this singular concept of giving power to the engineers to innovate on their own space, and then providing more space for innovation by abstracting out all the release related stuff into Jenkins or other tools that can be composed by picking up the right stuff. And here is the best part. This is the homegrown tool that I was talking about, which is actually using Jenkins and composing all these actions. You see that it's not very visible. I'll read a few out. The first one is about front-end deployment. The second one is about syncing the assets. You see test, and there is a traffic switch. All these are coming from a homegrown tool, but you don't have to rely on a homegrown tool. It is a need of the hour. We needed it, we built it, but there are market tools that do this kind of composition. It's possible. Argo CD is one of the ways you can do some of the automation. There are multiple tools. If you want to orchestrate, it's possible. So I mentioned a few points that are advantages where it is scaling for our ecosystem, for our scale, and the release triggers based on calendars is through this tool, which is employing Jenkins. And Jenkins is pretty much queryable. You can initiate a job and get a result back whether it succeeded or not. You can even get the last 10 results. We have health checks that are running, figuring out whether the last 10 health checks are successful to even dismiss an alert. So it's about extending the capability of each and every tool that we are using to the maximum limit of the potential for the tool. And the last part of this release, it does not end when we ship something, right? It starts when we ship something. We need observability when something goes live. And when you have multiple languages, you will ship logs and metrics to multiple places. It will be in different formats. That's not very conducive to recovering from incidents faster. Even debugging things are very slow when you have so many hops for a single request, right? We changed it. There is a brilliant observability platform within Freshwoks, which is centered around providing just logs, time series database, and traces. And I am an SRE manager. As an SRE function, I worry only about pushing metrics, getting things done on top of that by having alerts, having right dashboards. I don't worry about maintaining a database or access or anything. It's very similar to Jenkins. You see the pattern, right? All that is provisioned where I'm able to focus on getting the job done. And this is one of my favorite platforms that I use day in and day out. But that is made possible by the middle ground where you see an adapter. So if you use native shipper for every language, it will ship only one kind of format, one kind of metrics. But by changing that slightly, by adapting to a similar structure, you can pass through all the metrics to a single place. Today, all the platform, all the product related logs and metrics, I can check that in one portal. It's a time series database. I can query that. I can look at the data, the dashboards, which are all in a single place. I can go to any product. So this makes it easier to find out if I'm running into an error in my product, where it is coming from. That kind of, the next level of automation is also is possible through this kind of structure. Okay. And these are all some of the examples. I'll take 2-3 minutes and then stop it. This is observability for specific technology. This is about Tomcat. You can have Java, GC related metrics, etc. pushed to the same place where you are also able to ship the system metrics, which are 503, 5xx kind of errors. And this is blue-green related exception. If you notice, I'm not talking about general observability. I'm talking about observability between two different deployments. It's not single chart. It's two different things overlapped with each other, telling me whether we are at the same place after deployment. This is also two different things. Here it's also two different things. It's very easy to detect any anomaly visually, and also by querying things, it's possible to detect it. So that's how we manage many of our automation. And the last slide of this talk is this one, where when you start off as a small company, it is easy to have the same developer do DevOps and write deployments and do SRE, on-call, etc. But as we scale for multiple customers, multiple products and platforms, there is a need for release engineering as a function to innovate just for release engineering metrics. I'll connect the dot back to the DORA metrics that we talked about. If you want to have 1 hour, 1 day kind of lead time and multiple deployments per day that are all automatic, both forward and rolling backward is all automatic, then you need to have focused experts working on that problem. That's when we get to this kind of maturity, which is very closer to fully automation. And we support, the developers will support on their side, and the SRE team will support from the production side. The release engineering is the one that connects both the teams and get things done from a release engineering aspect. So that's all with me today. Thank you so much. If you are done, I appreciate the help.